Hi, everybody. It's Eric Dorward with the Spartan Rocketry Club for part two of our Estes Green Eggs build. In the intervening time, I have finished taking care of the fins, so they are all taken care of. And I managed to get, nope, not that piece. I managed to get the plastic part out of here, so we have a functional anchor point now. It actually came off pretty much as soon as I stopped recording, so go figure on that one. Today, we are going to do a little bit of work on the body tube, and we are going to build the motor mount, and we might even get a fin on. Who knows? So first thing we need to do, I actually already did, and that is I have drawn a line going through the middle of two of the cuts. This is where the launch lug is going to be. That should get done before we do anything else, because otherwise it would be a pain to get lined up properly. Next, we need to make the motor mount. So here is the motor mount. This is a 24 millimeter motor mount. It doesn't handle e-motors, so it's a short one, which, kind of unfortunate, I guess, but not a huge deal. Probably wouldn't want to launch this on an E anyway. All right, so we need to make some marks. We need to mark off 1/2 inch, 1 inch, and 2 1/4 inches from one of the ends. So 1/2 inch is there, 1 inch is there, and 2 1/4 inches is right about there. Okay, easy enough. Next, here we have our engine hook. The engine hook is going to go into the 2 1/4 mark. It's going to go like that. I, of course, need the knife. That is not a knife. Oh dear. They all have blue handles, so whatever. Here's the knife. I'm just going to cut slowly, gently. Try not to deform the motor mount too much. And then, there we go. Cut is through. So that takes care of the cutting, whether I did it with a brush or not. Okay, so just to make sure, that seems very nice. Okay, now over the outside goes this retainer, and this is going to go down to our 1 inch mark. So we need some wood glue. We're going to put the glue quite a bit before, truthfully. I'm not putting it right at the 1 inch mark because the retainer is quite thick. So that doesn't require any real accuracy. And truthfully, it doesn't require any accuracy at all. It's just approximately 1 inch. So there's something pushing back on the engine hook. Okay. There we go. So that is taken care of. Boop. The next thing we need to do is put the engine block in place. The engine block is going to go right up next to, like so, the motor mount. So it's not going to be right at the edge. I'm just going to eyeball in here and start so I can see the metal part of the hook sticking out here. So I'm going to put glue just in front of that and then try to make a circle the whole way across. That is, yeah, that's pretty good. Okay, then the block goes in, and I'm going to push the block in right up to the metal part of the hook that's sticking through, and that looks pretty nice. Okay, last but not least, we need the adapters here. You can, of course, cut these out using the hobby knife, but you don't really need to, provided you're gentle when you separate them. Yeah, they're going to be burrs, but the burrs are trivial at best. And in watching the last video, apparently I said burr like 35 times. My editor, that would be Mrs. Dorward, thought that was hilarious. Yeah, so here's the second instance of me saying that word. There are some burrs on this. They're not bad. It's not a big deal. You could sand it if you wanted to, but this is going to fit in the motor mount, or in the, not the motor mount, in the engine tube just fine. So don't worry about that. All right, so where do they go? Well, the one with the notch, that's for the hook. So I'm going to put that on this end. I'm going to try to put it on this end. There we go. I'm going to push it past the 1.5 inch mark. And this end, without the notch, that goes the blocked end. The end with the block, it's not actually blocked. There we go. And again, this is going to go right at the edge, so I'm just going to wiggle it past the edge. Now, glue. All we have to do with the glue is make a thin bit right at the end. I'm actually going to do both of the adapters at the same time, so I'm going to put glue right at the edge. So, and I'm also going to put it at the 1/2 inch mark. Just trying to be just a little past the 1/2 inch mark, because I'm going to scoot it through the glue. That's pretty good. Okay. This part is very easy. All you need to do is wiggle it back. And in fact, I'm going to move all my paper out of the way because I'm going to get it perfectly flush by just pushing, having this set vertically and then push it down. The downside of doing that is that it leaves a nice little glue ring there for you. I am also going to mop up the excess glue from the inside of this. Does that really matter? Nope. No, it does not. While I'm at it, I'm going to push this part, the top part, down to the 1/2 inch mark, which is hard to see because I have glue over top of it. Bummer. So let's actually break out the ruler. This kind of matters. In fact, it doesn't just kind of matter. It matters a good amount because the notches that have been cut in this have to be smaller than the marks. So if they weren't, that would be problematic. And in fact, sometimes when we do through the fin construction, this cut and this fin are going to fit exactly. So they're going to like abut this way. Now this one kind of does, in fact, because there's a notch like this, but we don't need to get both of them right. We just need to get one of them. So less important, but still, let's measure to make sure that we've done a decent job here. And that looks pretty good. I do want to check to make sure that the rings are straight up and down, so they're perpendicular. They look pretty good. Last but not least, for the construction. So I'm smoothing out the glue mess there, but we do need to put actual glue fillets on this because this needs to be strong. We are using 24mm motors on this particular rocket instead of the usual 18. So the most kick you get out of an 18mm motor is, well, an A83 has that 8 is kind of like, well, it's essentially the maximum thrust at any moment during the flight. So 8 newtons. It's not very much. 24mm motors, C's are usually C11s, and D's are usually D12s if you're talking about Estes gunpowder motors. I actually have some composite motors from Quest and Aerotech. They're actually 18mm size, but they fit inside. You can use an adapter to fit them in this. They have up to, say, 20 newtons, so that's significantly more. So this does need to be strong. I've never lost a motor mount. It's never shifted, but still, we do want to take good care of it. Now, that needs to dry. Let's get rid of the ruler because we don't need that. Now, the next step is we need to install the motor mount. We need to install the motor mount because, remember, it's going to go in like this, and at least part, I think the idea here is that the back end of the motor mount is going to be like this, right? So the fin is going to fit through the cut into the motor mount. Now, for this to work, this has to be very dry and very set. That is not the case right now. If I try to install this, I'll end up just ruining it. So that needs to dry, like a lot. So at this point, we need to take a little bit of a break and allow the glue to dry. Although I suppose before we do that, we could certainly put the launch lug on. There's no harm in doing that. So let's do that first. I have my launch lug line drawn on here. Now they just said to eyeball about midway between the two cuts, so it doesn't really matter. The goal, of course, is so that it does, it doesn't line up with the fins. So, okay, the instructions say we want to put the launch lug 6 inches up the tube. So 6 inches is right here. And again, is this something where we need to be incredibly accurate? Probably not. Wouldn't hurt. If we're going to do the job, we might as well do a decent job of it. So 6 inches. And then just glue the launch lug on. Simple enough. Here's the launch lug. Notice this launch lug is bigger than the usual launch lugs. This is a 3/16 launch lug because most of the time when you have an Estes kit, if it uses 24 millimeter motors, you're going to have to launch it off of a 3/16 rod, which we happen to have. At least I do. I actually like the 3/16 rod quite a bit. It doesn't wobble as much because it is stronger, it's thicker. 3/16 rods tend to be longer as well. So that is a significant advantage too. This is set really quickly. And just make sure I got it on straight. And it's not quite right. That looks better. Again, I'm just going to look down the barrel of it here to make sure that it is straight. That looks pretty good. You can also tell you want your lines to be going right through the middle of the tube, and that looks fine. Yeah, so while this is drying, the purpose of the launch rod. So you might think, okay, well, I have a rocket. It stands up like this. Why can't we just launch it like that? Why do we need to have a launch rod at all? Well, that would be fine if we had some kind of active flight control system like real rockets have, big rockets have. Ours don't have that. Ours have passive control in the form of fins. As it turns out, the fins don't really work very well to control the direction of the rocket when it is moving slowly. The purpose of the launch rod is to give some direction to the first few instants of the rocket's flight, specifically to point it up and as straight up as possible. So, when the rocket is moving slowly, in less than 10 feet per second or so, let's say, the fins don't really control it because there's not enough air moving past them. The rod controls it. And the idea is that if you build a rocket correctly and it's properly designed and all that, then it should get to the end of the rail, traveling fast enough, the end of the rod, fast enough so that the fins actually mean something when it leaves the rod. So there's enough air traveling over them quickly enough to actually direct the rocket's flight. That's why we need a rail or a rod. Do not, under any circumstances, try to launch a rocket just sitting on the ground without any kind of launch system, a rod or a rail. That's very unsafe because it could go anywhere. That's bad. We don't want that. I said rail a couple times. As it turns out, when you get into bigger rocketry, I do have a few rockets around here somewhere that have 1/4 inch launch lugs on them. And they naturally launch off of a 1/4 inch thick rod. And that's fine. I mean, they work, but there are a couple big design flaws, problems with that. One is this thing right here, there's only one of them, right? There aren't multiples to kind of balance out the aerodynamic forces that the launch lug causes. So just having the one means it's going to pull to the side a little bit where the launch lug is. So that's not super great. It's not significant really, but it's not zero either. This thing does cause a decent amount of drag. That's another problem. So if you were really concerned about how high your rocket's going to go, this is causing drag and it would be nice to eliminate it. The final thing is that if you're launching a particularly heavy rocket, a 1/4 inch rod is good for maybe an F power launch at best. But the more force you're putting into the motor, the more you can deform the a rod as it's launching. So the more it's going to swerve back and forth. And of course, you don't want that. So the solution then for medium and high power rocketry is we use a launch rail, which is uh, an inch rectangular. Well, it's not a rectangle. It's an inch square, and made of aluminum, pretty thick, strong aluminum, and it has a notch in it. And in the notch fits a little button, essentially, that you put on your rocket. So there are two buttons. So you would say, if this was a much bigger rocket, we'd put, say, a button here and a button here, and then they would slide down the rail and then launch from the rail. Rails are expensive. I built one just for funsies, and the rail itself is like 6 feet of this stuff. It cost $50, and the materials to build the rest of it were fairly inexpensive. It was PVC plumbing parts, but it was still another $50 easy. So it's expensive to build a system like this, but it is preferable. It really is better. And even smaller rockets like this, there are like micro rails that are smaller with smaller buttons. That would be an option. Anyway, that's enough of me yammering. This is still not anywhere near ready to go. So we're going to take a little break and let the glue dry for a little bit. Then, actually, you know what? We'll just do that in the next episode. These don't need to be 20 minutes long each. I probably rambled for like 10 minutes at this point. So good enough. We will let this dry and we'll do part 3 where we put the fins in. I will see you then.